All right, got both cameras set up, so hopefully I don't jack this up from either angle. Tools required, we're gonna need a long, this is a little too long, Phillips head screwdriver, 12mm socket. We'll need a 5mm Allen, and then a 10 and 12mm box end wrench. So let's just go ahead and get started. First thing, intake air temperature sensor. Very simple, we just unplug it. It's got a little release, and you pull it off. Oh, it's not wanting to release. All right, so let's start removing the air box. All right, one bolt. We'll go ahead and pull this off. I believe this has been changed. I'm pretty sure, if I remember correctly, this used to be a Phillips head. This is the intake air pressure switch. We're just going to remove it, remove the bolt, leave it attached, let it hang. This is our crankcase vent, so if you have a problem, it blows oil up into your air box, but it also helps the environment. Now this hose, okay, we were able to pull that off there pretty easily. Anyway, we just pull that hose off. We leave them on some race bikes. We'll put a catch can from the crank breather into a can instead of into the air box, but this is street application. Leaving this on is just fine. Now, what is the big Phillips head about? Well, in order to get to, actually on this one, we can get to the clamps up here at the top. Come over here. Same deal, clamps at the top. All right, I remember now. I didn't need this big giant long screwdriver. I will need it to pull the throttle bodies off through this hole, but right now, just to pull off the air box, that's fairly simple. You have to excuse me, even with my glasses, I don't see so well sometimes. And we'll just pull those off. Now, that should allow the air box to try to come off. There we go. Now we can go ahead and pull that connector off. You can see the air box comes off, and voila. Unlike some other motorcycles, here's our engine. That's pretty cool, right? That's one of the things that made the Suzuki, the Hayabusa especially, such a wonderful race bike. I mean, I'm not that far from getting the entire engine out of this bike. It's just really simple to work on these things. And I'm gonna show you that because I'm gonna go ahead and pull the valve cover off of this thing, and it's just gonna take a couple minutes to do. Hopefully this camera can catch it. So the first thing we're gonna do over here, we wanna get all of our stick coils off. So they're all labeled. As far as the harness, if you can see here, we've got a little number 4 on there. And for those of you who don't know, when you're sitting on the motorcycle, if it's an inline 4, the cylinder on the left is cylinder number 1. 1, 2, 3, 4. All right. Now, one of the things that I like doing, I personally mark the stick coils themselves. If you can see here, got number 4 on it, and I have 3, 2, and 1 listed or marked also. So this is nice in case we start getting into having to troubleshoot those. I can tell you what though, in 20 years, I really have only seen a couple of these ever fail. The OEM parts are brutally reliable. So just don't go chasing that. Chase anything aftermarket before you chase OEM, all right? All right, so now we're just gonna pull off this little protective rubber heat shield here and get it out of the way. All right, now there's a hole here. This is the cam position sensor right here. I guess you can see it on this camera better. I'm just gonna unplug that because we don't need it. Same deal, they're just little quick disconnects. And now I'm gonna go grab a removable tire wrap real quick and just, actually I can just sort of tuck it under here for now. All right, now I do remember that in order to get the valve cover up and out, you have to pull the cables off. Otherwise, you end up fighting with those. Another trick that I've learned, I've spent a whole lot of time trying to figure out which cable's which and wasting time. So now I just mark them. T for top, B for bottom, because they're actually switched. The bottom one is the one that gives it more gas. Top is the one that closes it. To me, that's a little backwards. So then I just mark them. I don't worry about that. And then your fast idle cable is here. It's pretty self-explanatory. You can't really mess this up. Basically, unscrew this enough to get it out of the little holder. Bring the wire, or bring the cable up, boom, done. And then we're just gonna do the exact same thing here. I'm not even gonna mess, hopefully, I can get the top jam bolts here loose enough to where I don't even have to touch the bottom ones, because if I can do that, it'll just make it so much easier to put everything back together quickly. And remember, at the racetrack, you don't have 20 minutes to figure out which cable goes where, you know what I mean? So all these little tidbits help. And quite frankly, it's stuff that if you don't learn them and your competition does, you're at a big disadvantage. Okay, so now I can see the valve cover right here. There are a measly 6 Allen head bolts holding it on. But one of the things I do want to do, this bike's a little dirty. I'm going to clean some of this dirt off just to make sure we don't have to worry about anything falling down in the engine. I'm just going to wipe it off just to get any crud and debris and things just out of the way, so it can't fall in. And then we'll also cover it when we're not in use. It'll depend on how long it takes to do this video, of course. The beauty of the Suzuki's also, this valve cover gasket is reusable. I won't say indefinitely. They eventually wear out. Boy, you can have a cylinder head on and off and on and off and on and off. No worries of having to worry about buying new gaskets. All right, if I'm not mistaken, that's a 6mm. Yep. Grab my wrench, come over here, bust these loose. Oh boy, yeah, I wouldn't be surprised if the valve cover. Well, no, the valve cover had to come off this bike to be able to put the cam chain tensioner in. Hopefully, I'm not exactly sure who did it. I'm going to show you what we're going to do, because it's back to that same old thing. The aftermarket world does a great job of curing problems. I'm in it, I know. We sold and still sell a Hayabusa cam chain tensioner. Would I run it in my street bike for 25,000 miles? No, it's not what it's for. It's for race stuff. Race stuff means you've got to maintain it. The engine has to come out, and when the engines come out because you damaged them or you're just inspecting them or whatever, you readjust the cam chain and you're done until you do it again. That's not the case on the street. I have to get another wrench to get to those 2 back ones. All right. That noise you keep hearing is the battery charger telling me that the battery is fully charged. I just haven't unplugged it yet because I'm trying to focus on this. Now, in theory, the valve cover is ready to come off. About the only thing I'm going to worry about, there are some half moons here in the head, and they usually get a Suzuki bomb put on them, and they sort of get glued down. So I'm going to take a soft mallet and sort of lift and tap. There we go. That's the sound we were looking for. Tie straps, so I don't have to worry about this stuff hassling me. I like using our our removable ones from our straps, because you can use them over and over again. All right, getting pretty close now. Let's see where we are with our half moons. Ah, that one's in there pretty solid. Basically what I'm going to do here is just sort of put a screwdriver down there and just sort of lift up, get that half moon broken free. Same thing over here, and I'll show you what I'm talking about here shortly. Once those are broken free, valve cover comes off pretty easily. Wow, this one is really, really, really on there. Sometimes if you can't get them broken free, you have to pull the valve cover off and then peel them out. That's what I'm gonna have to do. We'll go ahead and just take the valve cover off. Let it come out of the groove in the head. Don't get me wrong. Oh, you know what? Now I remember, I do have to get to those throttle bodies and basically just pull them back. So go through that access hole here and get to the clamps holding the throttle bodies. Loosen those up real good. And then this pretty simple stuff. Actually, we'll pull this vacuum line off and pull this vacuum line off. One more thing. I'm just going to go ahead and get the throttle bodies completely out of the way. But in order to do that, I'm going to take them off. The idle adjustment. Remember when you could adjust the idle on your bikes? Wow. That's just got to come out. All right. We'll sort of route this up through here. Connector. This is actually where the power commander interfaces. And voila, throttle bodies are completely removed. Now I can come back over, assess my gasket situation. Oh shoot, now I remember I gotta take that off. It's all coming to me now. All right, now should be able to take off. All right, one valve cover removed. I'm just gonna go ahead, see if I can get the, if the half moons even want to come out of this thing. You know, they really don't, so that's okay. I'll just leave the gasket like this. We won't damage it, and we'll just put it back on the same way it came off, because I don't have quick access to gaskets anymore. I don't want to mess this one up. Okay, look at that. How long did that take? Now we can completely see the motor. I'm just going to wipe a little of this off here. Definitely going to need an oil change when we're finished. There's no reason to leave this sludgy stuff here. Really fairly clean for a Hayabusa. So what are we going to do now? The first thing I want to do, I'm going to perform a leak and compression check on this engine. Like I said, I think that the cam chain is the problem, but we'll measure leak down and compression before and after. Because if the cam timing has changed, the compression should also, well, no, it will change once we get it back to where it's going. And if we get an exceptionally low compression test, that also sort of validates what we have going on here. So anyway, let me get ready for that. That's going to require some different tooling, and we'll do that here next. All right, I am back. I got called away yesterday, so I had to cover everything up. This is nothing more, compression testers, nothing more than a gauge and a hose. There's a one-way check valve in here, so the pressure can go into the hose and into the gauge and not come back down out into the cylinder. So as the cylinder moves up and down, it builds pressure, it pressurizes the hose, and we get a reading. Before we start, just a word of caution. My fire extinguisher is still there where I put it previously. Remove the coils from the motorcycle. And when I say that, don't leave them plugged in and laying up here. If you're just doing this as a quickie test at home, I'll tell you a very quick story. A buddy of mine's car was running poorly. He decided to do a compression check. He pulled the spark plugs out, but left all the plug wires dangling on the engine. Well, he puts his gauge in, has his buddy crank it over, and his problem was he had a carburetor that had filled one of the cylinders with gasoline. The engine pumped over, the coil wires arced, it was squirting gas out of one of the holes because the engine was turning, and he burned down his garage, he burned up his car, he burned up his buddy's motorcycle, he burned up a couple jet skis, and he tried to burn down the neighbor's entire house. So don't let that happen to you. It's bad stuff all the way around. So we've already removed everything from here. And what we're gonna do, so what is a compression test? It's a general idea of how the cylinders are operating. What's the difference between compression test and compression ratio? That's very simple too. They're different, although one affects the other. Compression ratio is nothing more than a mathematical formula of the difference in volume between the piston at top dead center and the piston at bottom dead center. So if you have, at top dead center, let's say you've got 10 cc's of volume, and at bottom dead center, you've got 100 cc's of volume, you got a 10-to-1 compression ratio. It's math. Now, does that affect the cranking compression? Yes, generally, but it's more affected by camshaft, particularly duration. Duration's a big thing, but in this particular instance, we're really looking for something, and I just referenced the manual again. You're gonna find that you have to reference it quite a bit. In fact, let me grab it real quick. So, the engineers who built this engine have a standard compression ratio range, or compression range, of 171 to 228 PSI. That's a big window, right? The limit, if it's under 128 PSI, there's probably something wrong with the engine, and we're gonna have to pull it out and find out what it is. The max difference between cylinders is 28 PSI. So if you've got one cylinder that's just a little bit weak, generally you don't get one that's exceptionally strong. You'll get some that are weak, and then you'd have to go and fix it. But for this instance, this is just a quickie test just to see what general condition this engine is in, and should we go along with the repair, or should we put the brakes on and say, all right, we need to do something a little more in depth to fix this thing. So first and foremost, we will pull this out. I'm gonna go ahead and leave that there for now. Always cover your intake tracks. Another story, buddy of mine was building a Hayabusa. He goes to start it for his first time, and it makes a terrible noise. There was a screw in his cylinder, and all he could figure was it had to have fallen out and fallen down one of his intakes before he started the bike. So just keep them covered until you don't need them covered. And what we're gonna do for this, Suzuki has a little spark plug tool, a 16 millimeter deep well socket, does just fine. So we're gonna come in here real quick and just pull all these plugs out. Now, when I was troubleshooting the bike before, I had already replaced the spark plugs as part of the initial why is the bike missing. Now, there's a couple things you can do here. Just get it back to the magnet, or get it out with the magnet. You can see I already labeled this cylinder number 1. Cool little trick. We usually gap our plugs at 22 thousandths. That's just what has worked best in the past. So we continue to do it. But if you take a piece of tubing, it doesn't make any sense to gap your plug and then drop it 5 inches for that gap. Just take a piece of tubing, and then when it's time to put the plugs back in, just screw them in. All right, so we are gonna do that. Keep on going here. Also works as a handy dandy plug extractor. All right, now we have the plugs out. They are all labeled. Number 4, number 3, number 2, number 1. All right, so let's go ahead and look at these things. Reading the spark plugs. Fuel injected bikes are not like carbureted bikes. You're basically going to see a great looking plug all the time. But you can look look for anything that would make you go, oh, there could be something going on here. So if we take a look at these, they all look about the same. None of them are wet. None of them are particularly sooty. Are they all identical? Now, this is a stock motor with 25,000 miles. They're not going to be identical. And plus, you got some different tuning things going on since we pulled the power commander off. It's not tuned right, but I don't see anything that would in these plugs that would tell me, wow, we got a problem. So let's just keep on doing what we're doing. All right, so we will do cylinder number 1 first. Like I said, if you can see that, I had to turn that down to get it to fit inside the Hayabusa head. You may have to do the same thing, and you will definitely need an M10 adapter. You may have to special order the adapter. I'm not sure. I don't know how many cars come with M10s these days, but anyway. And all we're trying to do is get it to where it's all the way sealed. There's no ring, doesn't have to be crazy. Now I want to show you something too, and this is really important. We already have the throttle bodies off of the bike, okay? But it's very important, if you want a proper compression test, if the throttle bodies are on, you have to hold them wide open so you can get enough air inside the engine. I'm just gonna do this real quickly to show you what we get with this plugged up. By the way, I did have to put the battery back in because we got to crank the engine. So we're going to crank this up. Hopefully it doesn't suck my tape down in there. I have to pull it on the clutch. All right. So just after a couple cranks, actually, how am I going to do this? I've got an idea. Take another one of my handy dandy strap tie downs. Go ahead and let that do its job. I'm going to cover this up. Let's try this again. Just let the pressure out. I'm going to cover this up just like you had a set of throttle bodies without the cable, without turning them wide open, and see what we get. Okay. I don't know if you can see that, but it basically said 90 PSI. That's not good. But now, let's remove that, take the pressure off, and then all we're going to do, I'm just going to crank it over. The needle's going to continue to climb as it builds pressure, and then it's going to stop. Once it stops, I let go of the starter button. Okay, looks like we are right at about 107, I'm going to call it 173. So document that, cranking compression cylinder number 1, 173. Now, get rid of the pressure and move it over to number 2. All right, clear prop, and here we go again. Okay, if you can see that, 175. Turn the key off. Move over to cylinder number 3. All right, try her again. I'm going to call that 172. So right now, we're very consistent across the board, which is good news. Is that enough cranking compression? Once again, look at that window of operation Suzuki gives you. We can go all the way down to 128 before they think the engine needs to come apart. And then also, as I was mentioning before, if we do have a problem with the cam timing, that's going to affect the cranking compression also. But right now, we're just going to do a rough test. And so far, it looks like there's no reason for us to stop doing what we're doing. Let's try that one more time on cylinder number 4. All right, I'm going to call that 168. So that one is a little low, but you got a 28 PSI difference right now. We're looking at 7 PSI. So that's really pretty good. So that tells me that the engine is in decent operating condition. We're going to keep doing what we're doing. And in fact, I'm gonna have to pause right now and reset the cameras because now we're gonna get into a leak test. And while this gives you a general idea if the engine is damaged, the leak test will actually help pinpoint particular problems and issues. But let me get that set up and I'll be right back. Okay, for the leak down test, what we're gonna need is a compression tester. Now this is a fancy Mac Tools, really high-end, expensive thing. I used a junky one from Harbor Freight for years and years and years. It finally died, and I came across this one for decent money, so I went ahead and bought it. But basically what we're gonna be doing, there's two gauges here, if you can see them. One gauge is the cylinder pressure, or the amount of pressure coming in, and then the other one measures the leakage. So because I have over 100 PSI, my compressor is 120, you need about a 10 PSI more than what the regulator and gauge setup actually has. So I'm gonna set this at 100 PSI, and then when I put this hose, which does not have a check valve, but it does have my fancy little piece, I took it off the compression gauge and put it on this. We'll put this in the cylinder, and then we're gonna turn the engine to top dead center on cylinder number 1, then cylinder number 2, then cylinder number 4. Why? It's just more efficient. These things fire 1, 2, 4, 3. We'll talk about that later someday, I'm sure. But we're gonna test it at top dead center. So the theory is, if the piston's at top dead center, the intake and exhaust valves are closed, we put 100 PSI of pressure in there, and then we measure leakage. How much is leaking from where? It could be leaking past the intake valves, past the exhaust valves, could be leaking past the rings. I'll show you how to check for that, but we'll be able to tell exactly how much leak down this engine has and where it's coming from. If you got a bent valve, you hear it. If you got a bent exhaust valve, you hear it coming out of the exhaust. If you've got a bent intake valve, you hear it coming out the intake. If you've got bad rings or bad ring seal, it'll blow past the rings and it'll come out of this tube right here, because that's your crankcase breather tube, and you could actually hear, oh maybe, I don't hear so well anymore, but you can actually hear air escaping from one of those 3 areas, and that helps you fine tune what you might have to do. Generally, if you have a problem with the rings, you're gonna be pretty down on power and compression. This is a little down on compression, but not enough to worry about. I don't think we have a problem like that. Valves, maybe you need a valve job, maybe your valves are worn out. These have titanium valves, so you really can't do a valve job on the valves themselves. Of course you can on the head, but that's way deeper than what we're messing with here now. So let me go ahead and get this set up. So I need my compression tester, 8mm and a 10mm, and that's just to get, Suzuki makes it real easy for you to be able to maintain the engine and turn it over without having to pull a bunch of covers and stuff off. I'll show you what I'm doing with that right now. What we have to do is, first of all, remove this plug, and then also remove this plug. That allows us to get directly on the crankshaft. I can't remember what size, I'll need a socket for that. And this is a witness hole. Now, unfortunately, I don't think you're gonna be able to see down in there, but I'll do the best I can after I pull these covers off. All right, let's see if this will come out. Sometimes they are stubborn. Oh, geez. And sometimes you damn near have to break them to get them out, and that would be no good. Good. When in doubt, get a bigger hammer. If this doesn't work, we're going to have to try heat. We don't want to do that. But I don't think we have a choice. We also don't want to strip this out. All right, just because we're not a big fan of open flames around the engines, we'll try the heat gun here. Boy, not liking it. We're getting ready to strip that cap out. Whew, looky there. We did it. That one was tough. I promise you that this hasn't been pulled off in years. All right, there we go. We did it. So now, all right, good as new. We'll make sure we put some anti-seize on these threads before we put that back together. Now, generally this one is not nearly as difficult. Please don't make me a liar. All right, it's coming to me now. Looks like maybe a 14. All right, 14 millimeter. Now we want to have some leverage because we're going to be turning on this, turning the engine over. Your engine spins clockwise. Clockwise. Whoop, 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 whoop. All right, now this might get a little tough. Reposition the camera here. I'm just going to grab me a pointer. You see this little slot? That is there as a reference mark. Now, on the crankshaft, you've got some numbers, and I don't know. And what we're trying to do is turn this to where we're at top dead center on cylinder number 1, which is also going to be top dead center on cylinder number 4. Okay, there's a line, and I don't know if you can see that. I'm gonna move it back. Now, one of the things you wanna do, you don't wanna rotate the engine backwards often. Rotate it the way that it wants to go. But if you have to go back a little, rotate up to it. Now, when that line matches, can you see that? So basically now, this line on the crankshaft is matching this line on the cover. So we are at top dead center. I think that's a number 1 by that, but I'm gonna go ahead and check that out here shortly. 1 second, let me look at some things. All right, I'm gonna go ahead and move the camera back over so you can see exactly what I'm doing. But basically what we're gonna be doing is lining that mark up. And there's also another mark at 180 degrees out from that tells us top dead center on 2 and 3. So just keep that in mind. I'll be looking over here. You don't need to see this anymore. You know what it is. Okay, so this is very similar to using the compression gauge. Like I said, it is a slightly different hose. We'll go ahead and screw it into cylinder number 1. All right. Now what we're gonna do, take our air supply, hook it up, and you can see, come over here, I'm gonna turn this up to 100. If you gotta have 10 PSI more than what you're testing with. If you only got a 100-pound compressor, do it at 90. It's just a little bit different math. I'll show you that. It's just a lot easier. If I put this at 100, it's gonna be a lot easier. All right, right there, there's 100. Now, the piston's at top dead center, the valves are closed. I'm gonna put 100 pounds of pressure in there. On some bikes, especially seasoned motors that have a lot of miles on them, which means they've loosened up real nice. Sometimes it'll press the piston down and we'll have to hold the crank in position manually. Let's see whether or not we run into that on this particular bike. So all we're doing now, we're pressurizing it with 100 PSI. In a perfect world, it would leak absolutely nothing and this would read 100 PSI. It's not a perfect world. Sorry about that, my battery died. As I was saying, it's not a perfect world. Engines very rarely have 0% leakage. You can use different rings. Total seal rings do a great job of sealing if you got a good valve job. I mean, don't get me wrong, I've done engines before that had 0%, but something like this just isn't gonna happen. So let's see where we're at. I'm still at 100 PSI here. And then this is going to measure the leakage. Go ahead and put it together here. All right, did you hear it go vroom and then hiss real bad? That's because the engine turned over. Hold on a minute. All right, just as a quickie test, if I put my thumb over the hole, I can hear pressure start to build up as soon as I get close to top dead center on number 1. All right, I can hear it. So that tells me to come over here and look. All right, there we go. Now, how am I going to do this? All right, I've moved over to a breaker bar. Just going to try to hold this engine where it belongs. All right, I just want to show you this little piece of country heaven. Ordinarily when I do this, I work from the other side of the engine with a degree wheel for the purposes of this demonstration and the fact that I'm here by myself. If I had a helper, of course, they could hold the wrench. But I just went ahead and put a socket and a breaker bar and just strapped it here to the frame to hold it at top dead center. Now I've pressurized it. I'm going to adjust this gauge, give it a slight adjustment because my compressor kicked on. 100 psi in, out, look at that, 98, 99, and I don't know if you can hear that hiss. Nothing past the intakes. Nothing past the exhaust. I hear no leakage at all. So that means this tube, really very little. That's great. If all the cylinders are sealed up like this, that just tells you what a fantastic engine Suzuki has. So I'm going to go ahead and put cylinder number 1 down for 1% leakage, and now we're going to move on to 2. Now I've got it in number 2. Right now, piston number 1 is at top dead center on the compression stroke, or the power stroke. Now we're just going to rotate the engine 180 degrees, and number 2 will be at top dead center, ready to measure. 180 is pretty easy with the breaker bar here. All right, I want to show you what we've got going on here because it's a little different. Now when we look in the hole, you don't see the mark. The mark for top dead center on 2 and 3 is actually this little small mark right there. It's sort of hard to see, but right where my pointer is, there's a little mark, and that's top dead center on 2 and 3. All right, try this. Wow, I don't know if you can see this, but with this set right at 100, we are looking at 98, so 2% leakage. So far, cylinder number 1, 173, 1% leakage, 175, 2% leakage. Let's go do 3 and 4. 1, 2, 4, 3. I get one of those little diagrams that show how these things are working when the valves are opening and closing. I'll put a link in the description for you guys. All right, this is actually really cool. Pull this back, dial the inlet pressure up to 100, and what do we have on the gauge? Exactly 100. This cylinder has basically 0% leakage. That is really, really good, but could also be bad if the cylinder has oil in it, but we're not going to mess with that right now. So we're going to put cylinder number 4 down as 0%. That's how stuff falls in the engine. Brock, put that back. All right, last one. Oh, I definitely hear more out of this one. Let me check and see what we got here. No, according to the gauge, this is right at 99% leakage. So I can hear little. It's coming past the rings. It's not making it to this hose, but I can hear it through the cam chain tunnel here. So That's minimal leakage. So what that tells us right now is this engine is in a very good state mechanically. So now we're gonna go try and find the miss, because it's not compression, right? We've taken compression or a dead cylinder or anything like that basically out of the equation with these tests. Now we're gonna go dig a little deeper into exactly what is wrong with this, and we're gonna do that by checking the cam timing. I'm gonna go, or not cam, well, the timing of the cams, not the actual cam timing. We may do that anyway, just for a reference to show you what's up. But I'm gonna have to do a little bit of work, put a degree wheel on this thing, because I don't wanna fiddle with the, I don't wanna fiddle with this whole wrench deal. If you're doing this at home, right now, if you had a bike with a question, man, it's ready, basically ready to go back together. But because you've got the valve cover off, why not check the valve lash? Why not document the valve lash? I'm gonna show you how to do that and more next time. I'm tired. I wanna go do something else for a minute. Oh, by the way, it's hot in here too. See the gleam of sweat? Can't have my air conditioner on because it's too noisy and messes up the sound. This is all for you guys. This is what we do for you. Dang, I wanna be you. Hey guys. I couldn't help myself. I wanted to just go away and do something else because I'm hot, I'm tired, and done this about 100,000 times. That's a good place to show that picture of me with my head gaskets, to show what the kind of dues that I paid to get to this point to know what I'm doing. Anyway, I was curious. I just wanted to know whether my hypotheses, since the engine seems to be in really nice condition, especially for the mileage killer engines, I wanted to find out, did it jump cam timing? And we'll get into this in more depth in the next episode, but just to sort of show you, let me pull the camera off here. All right, when I say cam timing, it can mean several different things. What I'm talking about now is, are the cams timed to OEM specifications? That's all, no adjustments, no nothing. Are they installed correctly? So what I did, I went back down here and I put it at top dead center, and then I had to go ahead and remove that gasket. I tore it up, so I'm gonna have to order another one because it was just silicone to death over here. I don't even put silicone there. I've never had one leak with no silicone, so I don't know why you gotta glue it, but the manual says so. So I guess the last mechanic who was in here decided to do that. Anyway, when you install camshafts, you don't just randomly put them in. Step number one is have the engine at top dead center and have your exhaust cam. There's an arrow. Can you see that arrow? All right, you see that arrow on the exhaust cam? I'm gonna move this like that. That arrow is supposed to be level with the surface of the head. So here's the surface of the head. The arrow's way up here. So what does that mean? Well, it's simple. That cam is not in the OEM location. It has jumped what looks to me to be one tooth on the camshaft sprocket. One tooth off will most definitely cause problems like this. My guess is, and we'll get into more in-depth detail, but right now there is no doubt the cam timing is wrong in this bike. That's probably what's causing the problem, but I'm gonna show you how wrong it is, because I'm sure the intake is off at least one tooth also, and that's where you really start getting into the problems with the miss. So I will get into more detail on that in the next episode. I just wanted to test my hypotheses, and it looks to me like the cam timing is indeed wrong. So we're gonna fix that. We're gonna document some more stuff. I'm gonna show you how we do it all. Until next time, I'm Brock from Brock's Performance. Remember, if you want to support our channel, like and subscribe, but also go to brocksperformance.com and buy some bike parts. I got to pay all the people that put all this stuff together for me, you know.